Hello, welcome to this Python course. This lesson is about immutable data, mutable data, lists, and strings. It is good to know that some data types in Python are immutable. An immutable data type means that the data cannot be changed. And the immutable data types in Python are the scalar data types, the int, the float, and the bool, and also the sequence types string and tuple. So how does it impact your programming when you know that data cannot be changed? So for scalar variables, this fact is not very relevant. Variables can be assigned to new data values, as shown in the code below. There's data value 1, avar becomes a name for this data. We compute a new value by adding 1 to avar. So we get a new value 2, and avar becomes a new name for this new value, and we can print it. So what happens is a new data value is generated. So we don't change the 1, but a new value 2 exists, and avar becomes a name for that. So assignment does not change the data, but gives a new name to new data, or it gives the same name to new data. For the tuple and string, it is more relevant to know that they are immutable. Let me show the code. T is a tuple with 3 values, and we can print the first element of t being 1. So index 0 means the first element. If you want to use a similar code to change the first element, so to assign or to store the value 2 in the first element of the tuple, this is not possible, and we get an error message. So maybe it's good now to also look a bit at these error messages, because you will get those definitely when you start programming Python. So what Python tells you, in this case, there's an error, and this error is called type error. It's a type error because we want to do something with a tuple which is not allowed for this type. At the bottom of the error message, we can see what is the cause, what is the issue. The tuple object, the t, does not support item assignment. So we can't assign to a single item in t. The error message also shows on which line the error occurs. Of course, in this case, it's quite simple. It's this line. But for a long piece of code, this can be helpful. And for a string, exactly the same story holds. H, in this case, is a string with value hello. We can print element 2, for the element with index 2, which is an L. But if we want to change, for example, the first element into a capital H, this is not possible, and we get an error message, which is similar to the previous one. The str object, the string object, does not support item assignment, and this is the offending line. So this also implies that any operation that you do on a string can never change a string, so it will return a new version of a string, a new string basically, which is updated or adapted. So are there ways to have sequence types that you can change? Yes, of course. In Python, those are called lists. The type and the list is very similar to a tuple, but it's written with brackets instead of braces. This is an example. So this looks like a tuple, but it is not, because this one has brackets. This means this is a list, and of course you can print the list and we would see 1, 2, and true in brackets. And for a list, we can change elements. So in this case, element 2, this value, is replaced with the value 0. And we can print the results, and that true has been replaced with the 0. Of course, we can changed lists in more ways, not only change the value of a certain element, we can also change the number of elements in the list in several ways. The first is by appending elements at the end of the list. This is a syntax, a code that we will see more often. This is a function, and this dot means apply this function on this object. This object is a list, so we're going to append to this list the value 3. So the result of this is a previous list with 3 appended. Another example of changing a list. In this case, we are going to concatenate, so we're going to construct a new list which consists of 2 parts. First, the elements of this list, and then the elements of this list. And this plus means concatenate, because these are both lists. And my list will become a name for the newly generated concatenated list. This is how it looks. The new my list has first these 3 values and then the previous values from my list. So in this case, the concatenation doesn't change my list, but generates a new list, and then my list becomes a name for this list. It's also possible to extend my list, so to concatenate my list and change my list itself. That looks similar to the append. Extend means add this list at the end of my list. So this is similar to this concatenation, but in this case, we're going to change my list itself. And here, my list will become the name of a new list. The effect is similar. This is the original list, and we extend it with these 3 values. Next to adding elements, we can also remove elements. The function that we can use for that is pop. Pop in this case removes the last element of the list. It also returns the value of this last element. So after mylist.pop and making last element the name of the returned value, we can print the last value and the resulting mylist. 6 used to be here, has been removed. Last element now is a name for the value of the previous last element. And we have a new list where that last value has been removed. Instead of removing the last element, we can remove basically any element in the list by specifying the index of the element. So in this case, we're going to remove the first element of the list with index 0. And again, the value of this first element for that first element will become a name. So if we run this code, we see first element becomes 4, this 4, and the list has 1 value less. The first element has disappeared. Another way of manipulating elements of lists is to use slicing. Slicing can be used to get a selection of elements in a structured way. Slicing looks as follows. This is the list that we're going to slice. We use again the indexing operation, but instead of having only 1 index here, we may have 3 values separated with this. The result is a new list, and sublist will become the name for this new list. So what do these values mean? So how do they affect what the elements that you would get? First is the index where to start. So the slicing will start at first. Last is where the slicing will stop. Or to be more precise, last is 1 beyond where we're going to stop. So we would run until, but not including, last. And step specifies how many steps the next element to go to the next element. So if step is 1, we would take every element. If step equals 2, we would take every other element. These values don't need to be specified as long as the columns are there. If you leave out first a default value of 0, the first element will be used. If you leave out last, a default value of 1 beyond the last element will be used. And if leave out step, a default value of 1 will be used. So if you leave out all these values, you will simply get a copy of all elements. You start at the first and at the end, and you take each element. It's good to know that also that slicing here is introduced for lists, but can be used for any array-like type. So I'm going to demonstrate this theory with some examples. In each of these cases, I think it's good for you to think ahead what will be printed. Maybe pause the video, think, and then check whether it's correct or not. So we have here a list, my list, with 10 elements ranging from 0 to 9. And we will do all the slicings on this list. This is the first slicing operator. As you see, we only have one column here. You can leave out the second one if you don't need to specify step. So in this case, all 3 parameters, first, last, and step, take the default value, which means we start here, we end here, 1 beyond the last. So we go up to including 9, and we have step 1. So this will return a copy of the original mylist. A bit more complex. We start at 1, we run up to and not including 4. So we will select element 2, 3, and 4. Another example, we start at 5, that is 0, 1, 2, 3, 4, 5. We start here, we end at -2. This is -1, the last element. This is -2. So we run up to 8, not including 8. So this slicing will return these elements. And this is again the same as this one. Here we don't specify any parameters and we simply get a copy of the whole list. Some more examples with negative step sizes. Here we specify -1, which means we're going to move from the back to the front. So the step is negative, so we stop backwards through the list. If we don't specify the parameters, then in case of negative values, their default values change. Of course, the first now is 9, and the last one is here before the start, which means that this will simply return the reverse list. Another example, in this case, first is 3, 6 is 1, last is 6. In this case, also we have a negative step, but these are not the default values, so these are really interpreted as is, which means we start at 3, we're going to step in the direction to the front until we arrive at 6. It's clear we will never arrive at 6, we won't wrap at the end. So this means this is an empty list. We don't get an error message, which is convenient. We simply get an empty list returned because there are no elements in this range, because we step backwards and the start is smaller than the end. So if you want to get the range between 6 and 3 in the reverse order, we should start with the largest element and then have the smaller one and then again -1. So this will return, we start at 6, we go 2, 3, but not including 3, stepping down. So we will have 4, 5, and 6 in the reverse order. And this is again a default value, so this means run until the end. We start, this means start at the end. So we start at 9, we run up to 6, not including 6, in backwards direction. So we just will get 9, 8, 7. Assignment, you can also assign to a slice, and that means replacing elements. I'm going to demonstrate that as well. A smaller list from 0 to 7. And a slicing operation. By now you should know what this means. We start at 1. Yeah. We go until the end, and we take steps of 2. So this means we select this one, 3, 5, and 7. So this gives the sublist, let's say, starting from 1 until 7, where we only select every other element. Note that this construction is to the left of the assignment. So this doesn't return a list. What it gives is an option to change these elements. So we select 4 elements, and we can assign a new list to these 4 elements, which means the first element will be used to replace this one. This one will be used to replace this one. This one will be used to replace this one, etc. So if I demonstrate it here, this is the original list. And after this assignment, all these elements have been replaced with a negative value. So if you use a slicing operation at the left-hand side of an assignment, that can be used to change the elements inside the list. So you can try this for yourself to see whether you can do some slicing operations, for example, like these. Implement it, think in advance what would be the result, and check by running the code whether you were right. I've mentioned a few times already that assigning is giving a name to data. And for mutable types, such as the list and many other types, basically all types except string and tuple, this is good to know. And it's also good to know what happens in this when you copy lists. This is an example to demonstrate why it is relevant. This is a list with 3 values. A becomes the name of this list. In the next line of code, B becomes the name for the same thing for which A is a name. So after these 2 lines of code, there is one list with values 1, 2, and 3, and there is 2 names, A and B, and both A and B are names for the same list. And of course, if we print A and B, we would get printed twice 1, 2, 3, and these are not 2 lists, this is the same list. So what happens if we change A? If we change the first element of A and store 3 there, we can print A and we can print B again. If we print A, we see the changed list. And if we print B, we see the same changed list. And of course it makes sense because B is yet another name for the same list. So if we change the list, but you print it via A or via B, you will print the changed list. So A and B are names for the same data, and if A is changed, B automatically changes. Well, yeah, because B points to the same data. So if you don't want this, if you want to change A without changing B, you should make a copy of A. This is how it looks in code. This is the same list again. A becomes a name, and B becomes a name for, here we use slicing to create a copy. A slicing at the right-hand side of the assignment gives you a copy of the list. So after these 2 lines, there are 2 lists. This list, 1, 2, 3, and another list which has the same contents, the same length. And the first list has name A, and the second list has name B. Again, we can print them, and then we can change the first element of A. We can print them again, and then we see A has changed, but B is a different list, and B has not changed. So I want to finalize this lesson with some information on strings and manipulating strings. So strings are used to represent text in a Python program. You may have already seen in the earlier code examples that strings can be enclosed in double quotes or single quotes. And strings can even be enclosed in triple quotes. And if you use triple quotes, you can even have multi-line strings. So you can index strings to get a single character. A single character basically is still a string, but it is a string of length 1. If you need to create a very long string, you can use the / character to combine two strings. So in this case, long string will be a string that runs from A until P. They will be more or less concatenated because of this /. Inside a string, you can also introduce special characters using a /. If you have \n, you will get a new line in your string. If you use \t, you will get a tab character. And if you use //, there should be 2 backslashes here. That will become 1 / in your string. If you're using Windows and you need to manipulate paths with text strings, then you often need to enter strings with a /. And then to get the /, you need to put 2 backslashes here because of this rule. That may be inconvenient, and if you want to prevent this / stuff, you can prefix your string with an R. So you have the same string, put an R in front. That means it's a raw string, and that means that Python will not start to interpret these backslashes. It will take the string as it is. So some examples. Here we have a string which is enclosed in triple quotes, and of course the first quote must match the last quote. And then if we print it, we can have text with single quotes, double quotes, without problems, because you have several ways in which we can tell Python where the string starts and where the string ends. Strings can also be concatenated by addition, the same as adding tuples or lists. So in this case, we're going to add 2 strings, and that these strings have this one single and this one double quotes does not really make a difference. And you can do many operations on strings, and they, as said before, they will return a new string. I will show some functions that you may use in your code. In this case, S1 is a string A, B, C, D, E, and this syntax we have seen before. Upper is a function that we call for S1. This will change S1 into uppercase, or basically it will create a new string which is S1 but then in uppercase. This does not change S1. So if I run the code, after this statement, S1 is still the original string, can't be changed, and S2 is the new string with capitals. You can also apply slicing and indexing to strings. This will give you the second element with index 1, and this will give you the elements with index 1 and index 2. So it will be B and C. Some more advanced operations on strings. You can search for substrings in an existing string. It's the find operation. What will return is the position where this substring is in this string. So in this case, CD can be found here. The index of C is 0, 1, 2, so this will return 2. And you may wonder what happens if the substring cannot be found. For example, like this, BD string is not present in this string. And what is returned is -1. It is obvious that -1, because -1 is not a valid index for a string, it's obvious that something went wrong, or at least that the string can't be found. It's also convenient that Python doesn't give an error message, but simply returns a value that tells you that this substring is not present in the string. You can also replace substrings, for example, BC with another string, which can even have a different length. That's not relevant. And this result, as expected, replaces the BC with twice BC in capitals. Another often used function is split. Split will split the original string in substrings, and it will make those splits at these locations. So at locations where there is a B. In this case, it means this string will be split at B. So we will get two substrings, one with A and one with C, D, E. So the B's are not present in what is returned. The result of this split is not a single string, but it's all the substrings, which are put in this case in a list. So the split returns two substrings in a list, and also a single, and it doesn't change as one. So to summarize this lesson, scalar types are immutable. Tuple and string are immutable array types, which means you cannot change values in these and you can't change their length. If you want to have a mutable array type, you must use a list. Slicing can be used to access subsets of elements of a sequence type. That works for lists, but also for tuples and strings. And for slicing, you need to specify 3 parameters: where to start the slicing, one beyond the last element, and also the step size to take to go to the next element. A negative step size means stepping backward. String objects have many functions for string processing or text processing in general, and those functions generally return a new string. So I want to end this lesson with 2 exercises. One is to use slicing to replace 2 elements, the third and the fourth, in an original list with new values. The second one is to manipulate a string with characters and create a string with upper and lowercase versions of this string. Example implementations of these exercises are also in the Jupyter notebook.